Welcome to our YouTube channel. This is Ernest coming to you from MathLab Tutorials in Toronto, Canada. Although seemingly impossible, like many other contributors on YouTube, our mission is to transform some of that destructive hate energy into constructive love energy for a subject that is so deserving. Mathematics is part of all that surrounds us. Just pause for a moment and take a good look. As your screen suggests, like it or not, math really did take us from the Stone Age to the Space Age. The sermon is over, and now let's get down to some serious math. This is video 3 of the video series on radicals, and we'll continue to perform operations on expressions containing them. Let's look at question 4, rationalizing binomial denominators. To rationalize means to remove radicals. We saw that in the last video. Binomial means two terms, and of course we're rationalizing denominators. It's very rare that we need to rationalize numerators. We're just going to be rationalizing denominators. Here's the key formula for this problem set to follow, aka identity. And we actually developed this identity. When you see an expression of the form a all over b root c plus d root e, you can always multiply top and bottom by the conjugate of the denominator. Okay, you'll recall that if we have an apple plus a banana, the conjugate of apple plus banana is apple minus banana. So all we do is pick up this expression and put it on top and bottom and change the sign in between, and we will have our conjugate. So we'll multiply top and bottom by the conjugate. That's perfectly legitimate. It's like multiplying an expression by 2 over 2, which is essentially 1. So no problem there, as long as you don't multiply by 0 over 0. So we're going to multiply top and bottom by the conjugate. On top, we have a bracket, b root c minus d root e. That's no problem whatsoever. On the bottom, like I said, we have like an apple plus a banana times an apple minus a banana. That's of the form x plus y times x minus y. When you expand x plus y times x minus y, being conjugate pairs, we get a difference of squares, x squared minus y squared. Now we identify the x as b root c, and we identify the y as d root e. Okay, so we have x plus y, x minus y, x minus y. When you expand the denominator here, you're going to get x squared minus y squared. Now x squared is b squared root c, which is just b squared dot c. And y squared is just d squared dot root e, which is d squared dot e. And there you go. That's the x squared minus y squared, x squared minus y squared. And the radical is, all the radicals are gone, and that's what it means to rationalize the denominator. When the radicals have all been annihilated, then we say that the denominator has been rationalized. The numerator, no problem. You can do a bullet, target. You can do whatever you want. You can leave it the way it is. The bottom line is that we've rationalized the denominator. We've removed all the radicals. So if we summarize what we've done, we've taken this expression, we drop it down, and we produce this alternative expression, and we dropped it down here. And of course, the left side is identically equal to the right side, and that's why we use a triple stroke. Okay? Now, there are a couple of restrictions. We certainly need c and e to be greater than or equal to 0, because these are the arguments of the radicals. Over here, the square roots have arguments c and e, so we want to make sure that c and e are both greater than or equal to 0. And also, you want to make sure that c and e are not simultaneously 0, because if they are simultaneously 0, the denominator becomes 0, and we have a over 0, which is undefined, okay? So just beware of that. Here's an example which makes use of this identity. If we have 5 all over 2 root 3 minus 3 root 2, we look at this and identify it with the left-hand side. The a is 5, the b is 2, the root c is root 3, the d is minus 3 this time, and root e is just root 2. Okay, so now we can use this formula over here. The a just gets transferred over. The conjugate of the denominator is just 2 root 3 plus 3 root 2, no problem. And then the new denominator becomes b squared c minus d squared e. So it becomes 2 squared times 3 minus 3 squared times 2. 2 squared times 3 minus 3 squared times 2. And voila, the denominator is radical-free. All you need to do at this point is expand the numerator and simplify the denominator. When you expand the numerator, we just get 10 root 3 plus 15 root 2, no problem at all. And when we simplify the denominator, we get 4.3, which is 12, and 3 squared is 9.2 is 18. So we wind up getting 12 minus 18. And of course, 12 minus 18 is minus 6, and we just copy-paste the numerator. Finally, because the minus 6 doesn't look nice down there, I chose to multiply top and bottom by -1 to get rid of the minus sign on the bottom. This operation over here is completely optional. If you don't want to do it, there's no reason to do it. Just to make it look pretty, I multiplied top and bottom by -1. When you do that, you can distribute the minus sign right across, and you get minus 10 root 3, minus 15 root 2. On the bottom, -1 dot -6 is just 6, and voila, we're done. Okay, let's go on to the next slide. We're going to do some problems now that require rationalizing the denominator. Let's look at A. We have 1 all over root 2 plus 2. Recall that the first thing you do is look at the conjugate and put it on top. Of course, that 1 is really an imaginary 1 out front. If that number were like a 5, you'd put it down. You put brackets around here, so that's no problem. Now, to get the new denominator, there's really a 1 in front of the root 2, so you do 1 squared dot 2 minus 2 squared dot 1, because there's an imaginary 1 here, which can be written as the square root of 1. So altogether we have a 1 squared dot 2 minus 2 squared dot 1. On top we just get root 2 minus 2. On the bottom, 1 squared dot 2 is 2. And 2 squared dot 1 is just 4, so we get a 2 minus 4. And of course 2 minus 4 is -2. And then to make it a little pretty, we multiply top and bottom by -1. Again, this operation over here is optional. When we multiply top and bottom by -1 and reverse the order over here, we get 2 minus root 2 all over 2. And that just looks a little bit prettier than this, so we're done. Let's look at another one. We have a 3 all over root 5 minus 1. 3 gets transferred over. The conjugate of root 5 minus 1 is root 5 plus 1, no problem. And now dealing with the denominator. On the bottom, we really have a 1 over here, and beside the 1 over here, we have dot square root of 1. Okay, so we do a 1 squared dot 5, which I just simplified on the fly. Okay, or you can think about it like this, okay? You just do root 5 squared, which is 5, and then 1 squared, which is 1. Okay, just do it like that. It's easier. So you get a 5 minus 1, which is 4. And on top, if you expand, you get a 3 root 5 plus 3. And voila, we're done. Okay, so, let's go on to the next question. C. We have root 2 all over root 6 minus 3. And when we multiply top and bottom by the conjugate, essentially the conjugate goes up here. The root 2 just goes along for the ride. Here's the conjugate of the denominator. And now to get the new denominator, there's really a 1 out front. And we have a 3 dot square root of 1. So we write down 1 squared dot 6 minus 3 squared dot 1. So that's 1 squared dot 6 minus 3 squared dot 1. Now all you have to do is expand the numerator and simplify the denominator. When we expand the numerator, we get root 12. And we get root 2 times 3 is 3 root 2. And on the bottom, we get a 6 minus 9, which is minus 3. And now on top, I notice that root 12 can be reduced. Root 12 can be written as the square root of 4.3. And then the square root of 4 is 2, so we get 2 root 3. And then in the last line, we get 2 root 3 plus 3 root 2, all over minus 3. And because we can make that look a little prettier, completely optional, multiply top and bottom by negative 1. When you distribute that negative 1, we get minus 2 root 3 minus 3 root 2, all over 3. And voila, we're done. So let's have a look at the next question. D, the same sort of thing, except now we have two radicals, and we want to rationalize the denominator. So the first thing is transfer over the 2. That goes along for the ride. And then take the conjugate of that, put it on top. And then on the bottom, we really have a 1 in front of the root 6. So we have, or we can do it this way, okay? Just root 6 all squared is 6. Always a minus sign in between. Root 3 all squared is 3. And there you go. Okay, maybe that's easier for you. Just square each term and put a minus sign in between. Just square each term, put a minus sign in between. Okay, you'll recall that root 6 all squared is 6. Root 3 all squared is 3. Just put a minus sign in between. That's probably easier. Okay, so go ahead and do it like that. Okay, then all we have to do is expand the numerator. That's a bullet and 2 targets. We bring the bullet in. We get 2 root 6 minus 2 root 3. Done. And 6 minus 3 is 3. And we are done. There's nothing more to do there. And we'll just leave it alone. Let's look at the next one, E. It's very similar to this one here. We have 3 all over root 5 minus root 2. Again, transfer the 3 over. Take the conjugate of this, which is root 5 plus root 2. We're done with the numerator. And then on the bottom, just square. Square root of 5 all squared is 5. See, I'm just using that little formula I gave you in the beginning. But you can do it more quickly if you want. You can do the square root of 5 all squared is 5. Then put a minus sign in between. Always a minus sign in between. Because recall that conjugate pairs expand to give you a difference of squares. Okay? So the minus sign goes in between. And then root 2 all squared is 2. And then at the end over here, we're going to expand the numerator and simplify the denominator. When you expand the numerator, you get 3 root 5 plus 3 root 2. And then on the bottom, you get 5 minus 2, which is 3. And now I notice we have a 3 here, 3 here, 3 here. So you can do a triple cancellation. 3 goes into 3 once, into 3 once, into 3 once. And we're left with root 5 plus root 2. Okay, very simple answer. Okay, let's look at F, the same sort of thing. We have root 3 all over root 3 plus root 2. All we do is transfer the root 3 over. And then we look at the conjugate of this, which is root 3 minus root 2. And then all we have to do is square each term and put a minus sign in between. Root 3 all squared is 3. Root 2 all squared is 2. So we get a 3 minus 2. And then all we have to do is expand. Root 3 is 3. And root 3 dot minus root 2 is minus root 6. And then 3 minus 2 is 1. And of course, the 1 on the bottom does nothing. So we get 3 minus root 6 is the final answer. So let's look at the next slide. We'll look at G, getting a little bit more difficult, not much. We get a 2 root 6 on top and 2 root 6 plus 1 on the bottom. Again, the first thing you do is that the 2 root 6 gets transferred over in the numerator. Okay, it just goes along for the ride for the time being. And now take the conjugate of this. Okay, and I forgot that this should have been the conjugate, but okay, you'll go along for the ride for me. This should read 2 root 6 minus 1 and not 2 root 6 plus 1. So imagine that that's a negative 1. Okay, just bear with me on this. On the bottom over here, all we have to do is square. So 2 squared is 4, and then root 6 is 6. So we get 2 squared dot 6. And then a minus sign, and then we get a 1 squared is just 1 squared dot 1. And now all we have to do is expand the numerator and simplify the denominator. And when you expand the numerator, recall that this should be a minus sign, so you just mentally insert a minus sign in here. You get 4 dot 6, because 2 dot 2 is 4, root 6 is 6, so you get a 4 dot 6. Then you get a 2 root 6 dot negative 1 is minus 2 root 6. Again, that should be a minus sign. So altogether you get 24 minus 2 root 6. On the bottom you get 4 dot 6, which is 24. And then 1 squared dot 1 is just 1. So you get 24 minus 1 is 23. And again, I made a boo-boo up here. This should have been a minus sign. So this is a minus sign. I can't very well erase it right in the middle of the video. So use your imagination. That should have been a minus sign to start off with, and that's a minus sign to end off with, okay? So you can do the correction yourself. H, we have root 2 minus 1 over root 2 plus 1. Again, all you do is copy paste the numerator. There it is, but you need to put brackets around it. Okay, then the conjugate of root 2 plus 1 is root 2 minus 1. This time I did it correctly. You know why this sort of thing happens? Because I have to copy paste. When I copy paste, and then I forget to change the sign. Okay, because I'm using a math processor to type in all the math, so I often do a copy paste. So that's what kind of error you get when you do a copy paste. What are you going to do? Anyway, coming down here, obviously I didn't make the error here. This becomes a copy paste. There it is. The conjugate over here is root 2 minus 1. And then on the bottom over here, root 2 all squared is 2. And then always a minus sign. And then 1 squared is 1. And there you go. On top over here, this turns out to be a perfect square. So what we're going to do over here is do a bullet, target, target. In the denominator, 2 minus 1 is 1, so we don't have to worry about that. So when we do a bullet, target, target, that is to say distribution, we get a root 2 dot root 2, which is 2. And then root 2 dot negative 1 is minus root 2. And then negative 1 dot root 2 is minus root 2. And then negative 1 dot negative 1 is plus 1. And then when we gather up like terms, we get a 2 plus 1, which is 3. And then minus an apple is minus 2 apples. And we are done. Let's look at the next slide. Okay, a little bit more difficult, but nothing to worry about. In the numerator, we have root 2 plus root 5. In the denominator, root 6 minus root 10. Again, you copy paste the numerator. Just remember to put brackets around it. And you essentially copy paste the denominator, put it up here, make sure you change the sign. Unlike the boo-boo I made in the last question where I forgot to change the sign, make sure you take the conjugate of that and put it up there. Okay, so the conjugate of root 6 minus root 10 is root 6 plus root 10. Okay, so don't forget to conjugate. And now on the bottom, we get a difference of squares. Root 6 all squared is 6. There it is. Root 10 all squared is 10. There it is. And we put a minus sign in between. Okay, there I'm just using that little formula I gave you in the beginning. But you could do it by just squaring that, and putting a minus sign in between. It's completely up to you. Okay? I don't play hardball on things like that. Whatever works for you is fine by me as long as you do it correctly. Let's expand the numerator. We have a bullet, target, target. So let's expand. We get a root 2 dot root 6, which is root 12. And then root 2 dot root 10, which is root 20. Root 5 dot root 6 is root 30. And then root 5 dot root 10 is root 50. On the bottom, we get a 6 minus 10, which is negative 4. And now we have to reduce all the radicals in the numerator. Okay, the ones that reduce anyways, some of them won't reduce. Root 12 reduces is the square root of 4.3. In other words, 12 decomposes to 4.3. 20 decomposes to 4.5. 30 will not decompose into a perfect square. And 50 decomposes 25.2. Again, the 4, 4, and 25 are the perfect squares. I cannot extract a perfect square from the 30, so I have to leave it alone. In the next line, what I do is extract the perfect square from the radical. Square root of 4 is 2. I put it out front. I'm left with root 3. There's the bad guy. Square root of 4 is 2. I put it out front. I'm left with root 5. There's the bad guy. Of course, root 30 is all bad. Just drop it down. Root 25 is 5. Put it out front. And the bad guy is root 2. Okay, so that would be the final answer. You could, because there are no like terms over here. We have root 3, root 5, root 30, root 2. There are no like terms. The only thing you can do, if you really want to do it, is to multiply top and bottom by -1 to make this positive 4 on the bottom. But it's not even worthwhile doing, because then you have to distribute the minus sign right across the top, and all these positive terms now become negative. So you know what? Just leave it alone. Okay, leave it the way it is. Let's look at J. We have 2 root 7 plus root 5, all over 3 root 7 minus 2 root 5. We have to be just a little bit more careful with this one. Again, the numerator is just a copy-paste. Don't forget to put brackets around it. The denominator, take the conjugate and put it up top. Okay, I didn't make the mistake this time. I really did take the conjugate of the denominator and I put it in the numerator. And now we have to do a difference of squares. When 3 root 7 all squared is 3 squared dot 7. You see it, 3 squared dot 7. And 2 root 5 all squared is 2 squared dot 5. 2 squared dot 5. So on the next line, we're going to expand using bullet, bullet, target, target, and we're going to simplify the denominator. Okay, so let's go ahead and do that. We get a 2.3, which is, I made a little goof here. Okay, looks like 2.3 is 6. I put in a 2. Anyway, imagine like that 2 is really a 6. So I caught the error anyway, so imagine the 2 is a 6. And then root 7 is 7, so no problem there. And then we look at 2 root 7 dot 2 root 5. 2.2 is 4. There's the 4. And root 7 root 5 is root 35. There it is. And then root 5 dot 3 root 7 is just 3 root 35. And then finally, root 5 dot 2 root 5 is really 2.5. Okay, so the mistake over here, I forgot to put down 2.3 as 6. I put it in 2 instead. That really should be a 6. So you can go ahead and make the correction. Now all we have to do is collect like terms. Over here we have a 14, but it's really 6.7, which is 42. And then 42 plus 10 is 52. So this should read 52 instead of 24. Remember, I made the mistake over here. This 2 should read 6. So 6.7 is 42. 42 plus 10 is 52. And then 4 apples plus 3 apples is 7 apples. And then on the bottom we get 9 times 7, which is 63, minus 4 times 5, which is 20. 63 minus 20 is 43. Again, so this is the final answer, but this should read 52 instead of 24. So you can go ahead and make that correction. Let's see if there's anything left. And I don't think there's anything left. So that's over and out for this video. Thank you very much. Thanks to all for viewing this video. Stay tuned for many more videos to come. If you liked the video, please give us a like, submit comments, and subscribe to our channel. If not, please tell us how to improve it. Over and out from Ernest at MathLab Tutorials in Toronto.